So moving on to our second speaker, Ahmad Elgammal, and then we will have a question and answers period after the second talk. So thank you, Ahmad.
All right, so let me share my screen. Right, thank you for the invitation. So let me start my slides here. All right, so I'm going to talk about art and AI. It's a very big topic, but I'll try to be brief for the sake of the time. So basically, I come from academic background. From a computer science background in particular. So when we do computer vision and AI, when we look at images like that, we'll be very happy if the machine can recognize there is a woman, there's a man, there's a fruit, there's a tree in the image. That's basically what AI is supposed to do. However, we understand art is way beyond that. And art is, when you look at art as human, there are layers and layers of understanding and emotional effects that happens when you look at an artwork. So definitely AI is by no means able to capture all these layers of information and understanding, not on and even beyond that, the emotional effects of art. So that's why I really like to work on that area, and I've been working on that area for some time. Because I believe that basically the ultimate goal of AI is to make machines that have perceptual, cognitive, and intellectual abilities similar to those of humans. And by looking at art, any analysis of art, basically whatever analysis of art means, involve all these abilities. So in order to advance AI, we need to look at art and other cultural heritage artifacts. But that also help advance research in these areas as well, and that's what I'm going to highlight today. So I established the Art and AI lab at Rutgers about 10 years ago, in particular to focus on these problems. And I have been blessed to work with several collaborators from across the country. So, for example, I'm working with Professor Marianne Mazzoni, who is an art historian from College of Charleston, and Professor Elizabeth Dimore from the Fine Art at Rutgers, and others. And I have been blessed also to work with many students over the years doing their PhDs in this area. So here's some examples of the kind of research that we have been doing. I don't have time to talk about all of that. I'll just select 2 projects I'm going to talk about. So we have been working over the years on models to understand art at the level of understanding style, genre, artist style, and iconography and other aspects of art. We looked also on developing models for understanding artistic influences, how artists influences each other, and how can we discover these influences and quantify it. We worked on models on quantifying artistic creativity in art history and understand basically what they tell us about how art evolved over time. And we also worked on models on understanding how style evolved over time and how it changed. I'm going to talk about some of that today. So the argument I'm trying to make is that basically using AI and machine learning on understanding art can help at 2 extreme levels. At the very micro level, when you look at the brush strokes of an artist, that can be extremely useful. And at the macro level, when you look at millions of artworks or thousands of artworks, that will be also extremely useful. And both these scales, whether the micro scale or the macro scale, are beyond the human ability, because we definitely don't have the ability to go at the stroke level and analyze hundreds of thousands of strokes by an artist. It's beyond our ability. And when you go and try to understand what happened in art history by looking at hundreds of thousands of artworks over time, that's also beyond the human ability. And that's where AI really can complement our ability and give us some very useful tools. So let's start by the micro level to give an example. What role can AI play in the domain of attribution, authentication of art, given the whole spectrum of other techniques available? So there are a lot of technical analysis techniques available that analyze artworks at different levels, at the canvas level, at the under painting level, at the paint level, at the pigment analysis. There are a whole X-rays. There are a lot of techniques have been developed to understand the physical properties of a canvas, of a painting. However, when it comes to a stylistic analysis, it's always the human expert who has at the end to judge whether that art is by Renoir or not, or by basically Rubin or not, or Rembrandt or not. So the stylistic analysis has been always human judgment, and it's a very hard to make it objective judgment. Our goal is to really provide some scientific tools that help experts perform this stylistic analysis in a quantifiable way. We have been working on trying to analyze the strokes of artworks and understand if there's a signal to attribute the art based on strokes. And this is a paper that we had back in 2017 on this topic that we're going to talk about today. So the methodology here comes from authentication background. Basically, Van Dante was a Dutch expert in authentication, and he drove a methodology called vectology, where basically he claimed that there is a signal in individual strokes that you can catch that can basically identify the artist. Because basically this signal capture the spontaneity of how original artwork is being created in contrast to the inhibitory nature of imitated art. For example, a single stroke like that can be very different in the way it starts, in the way it ends, in the way the tone changes over the strokes. So all these are things that a human expert would look at. But you can imagine how hard is it for a human really to capture these characteristics and from something like the stroke level. So how can we use AI to help quantify this analysis? First thing, we have to exclude anything related to composition or subject matter related analysis, because this is the easiest thing people who fake works or make copies of works will do. You can easily copy the composition and anything else at that level will be not useful. Here are examples of artworks that have been copied. We ask basically artists to copy them. Some of these are the original artworks, some of them are copies. Just to tell you, basically, the people can really make very good copies of artworks if you get this to a talented artist. So it's not really hard to copy an artwork. It becomes very hard to tell just visually what is the original and what is the fake. So our framework basically starts by taking an artwork and segment the strokes, individual strokes, and try to quantify some shape characteristic of these strokes and some tone variations of these strokes using different AI techniques. And at the end, try to classify that art at the stroke level and at the drawing level. Here are examples of segmenting individual strokes or trying to segment individual strokes by the artist from a whole network of strokes like that. How to identify individual strokes, it's very hard task. Examples from Picasso, from Matisse, from Egon Schiele. And then here is an example of some signal. For example, if you quantify one feature, which is the curvature of the strokes, you can really see that Picasso curvatures of his strokes is very different from Matisse and very different from Schiele. So this is just an example of one feature that can carry a signal that can tell us whether this stroke is by Picasso, Matisse, or Schiele. But this among many other features. Also, we're using deep learning to really follow the stroke batch by batch and try to let the AI learn how the tone varies and the shape varies along the stroke. So here are examples of the results. Basically, this at the stroke level. So basically, from a single stroke, we can tell whether it's a Picasso or Matisse 79% of the time for ink drawing and 93% of the time for etching. If you combine all techniques, etching, ink drawing, pencils, and others, you can still tell Picasso from other artists by something like 79%, 77%. All these are different data sets have been trying, and these from individual stroke. So that means that every stroke has a signal that can be identified the artist with this accuracy. Can be used to identify the artist with this accuracy. If you go to the drawing level, when you can aggregate these results across all strokes on the artwork, you can also classify even higher levels between different artists. And moreover, you can actually tell fakes even better. Telling fakes is actually easier than telling whether it's a Picasso or Matisse or Shelley drawing, because when it comes to fake, the inhibitory pattern of the hesitance of making the strokes make it easier to catch these fakes. Here are some examples. In each of these examples, there is one real and one fake, and we'll show the analysis, how the analysis is done. So here, every stroke is given a color. Green is for real stroke, and red is for fake or unlikely real stroke. And at the end, we can identify this fake Picasso. Here's another example. One of these is real, and one is the most fake. You can try to guess which one is real and which one is fake. Now let me run the analysis, and you can see basically this is the majority of the stroke here. I have the signature of Matisse, while this is mostly fake strokes. Another example, one by Matisse, one is fake, and the same kind of analysis. All right, so now let's move to the total extreme, the other level, the macro level, and let's just give an example of what AI can do when look at artworks, millions of artworks or thousands of artworks. What can recognize, or what kind of patterns it can find. So we have been working on developing models for analysis of art. In particular, how can let the machine understand the way artists and art historians talk about art? Things like elements of art, space, texture, form, shape, color. How can you quantify these things? Movement, unity, harmony. So over the year, you have been working on developing ways to quantify each of these elements so we can measure them. In particular, one of the interesting things in art is the topic of style. So we know, for example, how artists vary their style over time. So this is the same subject matter here, which is the Last Supper, and you can see how artists over time, from Renaissance, even from Renaissance till now, have depicted the same scene again and again in very different styles. So the questions that really are interesting are what characterizes the sequence and evolution of art style change over time, and also what factors drive these changes in art style over time. These are really important questions, and we're trying to really build some computational models that help answer these questions. Obviously, some of them can be, or we can get some highlight of answers just by analyzing the form of the art, while others really are harder questions that involve more contextual, historical context and other social context that are beyond analysis just by looking at the art itself. But let's what kind of things we can get from just looking at the art. So this is a paper that we had back in 2018 called The Shape of Art History in the Eyes of the Machine. I'm going to talk about that briefly here. We know that machine can identify styles. The machine can learn what's a Renaissance and what's a Baroque and what's Impressionism and what's Cubism. That's good. But is there a relation between how the machine can tell the style and the way art historians look at style and identify it, and what that can tell us? So we started by looking at some theory from art history by Heinrich Wolflin, one of the pioneering art historian who pioneered the analysis of form in a way that separate the form from discussion about subject matter. And he had a theory about how can you tell the difference between Renaissance artworks and Baroque artwork in particular. And this series suggests 5 different elements of to look at to identify Renaissance from Baroque: linear versus painterly, planar versus recessional, closed form versus open form, multiplicity versus unity, and absolute versus relative clarity. So that's basically the 5 elements that he looked at, and he even mentioned or claimed that basically you can use these 5 elements to identify any other schools. So any variation in style has to go along these 5 dimensions. However, if it's true, can we prove that? Can we quantify that? That's really what we're trying to understand what the AI can do here. So we went into understanding how style is being learned by the machine. So we trained several deep learning AI models to classify styles, where our goal is really to understand what's under the hood, how the machine identifies styles. Here is an example of what the main findings. The main findings that we found is that basically when we trained the machine to classify styles, we found that 6 to 9 factors the machine learned can explain 95% of the variation, the visual variation in art history. In particular, we're talking about Western art history here over the last 500 years, from pre-Renaissance till now, mainly, or early Renaissance till now. So 95% of the variations you can see visually can be captured by a very small number of factors. In fact, actually, the first 2 modes of variations can capture up to 75% of these variations. And that's very interesting. What that means? So here, an example of the first 2 modes of variations. So these are the two important factors that you can use to visualize basically art history. And you can see here basically how art history evolved over time. And here's the interesting things. We color code this from every point. Here's an artwork. Just to clarify, every point here is a single artwork. And the color coding is the time. So this from 1400 all the way to 2000. You can see here how the machine learns style in a way that it puts things in a chronological order without giving the machine any information about time. You never tell the machine when the artwork is done. You never tell the machine that, for example, Rembrandt worked on 17th century or Picasso was in 20th century. We never told the machine that basically Renaissance came before Baroque, nothing at all about time. We just gave the machine images of art. The machine already put that in correct order. So when you look at the correlation with time, we find basically a very high correlation with time if you go clockwise like that. So basically here, that's very interesting. So we can see Renaissance here, moving to Baroque here, moving to 19th century schools of art, moving all the way to Impressionism here, and then you can see Cézanne coming here. You can see basically abstraction and cubism happening in the early 20th century here. You can see Pop art happening here. So it's very interesting how this arrangement happened here. So that actually resonates with Wolflin theory, because he suggested that basically change in art history can only happen in a sequential way, like a rock rolling down a hill, such that one thing has to happen before another can develop in form. So basically what Heinrich Wolflin suggested was totally correct, and we can really measure that and quantify that using AI. And this is something that's dominant across all models that we have trained. I'll try to be fast to finish on time here. So just in this figure here, what are these 2 axes here? So we find that these 2 axes here, these variables correlate the best with 2 aspects that Wolflin suggested: recessional versus planar, and linearly versus painterly, where basically these 2 aspects can really clarify what happened in art history in the last 500 years visually in terms of form. So in Renaissance, everything was planar and linear contours. When later in the Baroque, things becomes more painterly and recessional, depth and 3-dimensional representation become more dominant. And then all the way to Impressionism in late 19th century, where everything become very fuzzy and painterly in terms of contours, but still recessional And then came 20th century and Cezanne and where everything become planar again. Everything's become flattened again and planar again, until we go back and close the circle when things become planar and linear again, very similar to Renaissance. So we basically went over a whole circle in the last 500 years according to this representation. So I don't have time to go over more details here. I'll just jump into the conclusion. But there are many interesting things we can discover if we do this kind of analysis. For example, here the connection between impressionism and abstraction happening in 20th century, going through one artist in particular, which is Cezanne. So basically, how the machine here really find out a bridge in the data between impressionism and abstraction and cubism happening in the early 20th century, and that is through Cezanne, and this can be quantified, and we can actually see that bridge in many representations. All right, so let me just jump into the conclusion here. We just scratched the surface. I believe the science in the domain of digital humanity has a lot of potential, and I think everybody in the meeting here believes so also. Human and machine capture information at very different levels, and really we should benefit from this complementary nature in digital humanities. Thank you very much.